Hello everyone. Today we are going to discuss about double-ended queue. This double-ended queue, we simply call this as Deque. So it is a linear data structure, but the difference is that when we talk about linear queue data structure, insertion is possible only at the rear end and the deletion is possible only at the front end. Correct? But in this Deque, double-ended queue, insertion and deletion, both the operations are possible in at both the ends. That is rear and as well as front. You can perform both the operation. That is insertion and deletion. And it will not follow the first in first out rule. Our queue data structure follows first in first out, that is FIFO rule, but here this principle is not applicable for double-ended queue. So this is the representation of double-ended queue. Here this is a front pointer, so this is our front pointer, and this is our rear. So usually we perform insertion only at rear in our queue data structure, and deletion is only possible with the front pointer, right? But here insertion and deletion both are possible at front as well as at rear end. So this is the difference between our queue and Deque, that is double-ended queue data structure. And here when we talk about this Deque, there are two types of double-ended queues are available. One is input restricted queue and another one is output restricted queue. So in input restricted queue, insertion operation is possible only at front end. Okay, so this is called input restricted. In input restricted, insertion is possible only at the front end, and deletion is possible at both the ends, front and rear. So this is input restricted. And next type is output restricted queue. Like our input restricted, insertion is possible at one end, deletion is possible at both the ends. Here deletion is possible at only one end, that is rear, and insert operation is possible at both the end, that is front as well as rear. So in output restricted Deque, deletion is possible at one end, insertion is possible at both the ends. So these are all the operation, these are all possible with our Deque. Insertion at front, insertion at rear, deletion at front, deletion at rear. So when we are going to perform insertion at front, we have to check the condition like our queue operation. When we are going to insert any element into queue, we check the condition, that is overflow condition. The same we have to check here. Okay, so before implementing the operation, we have to check whether the queue is full or not. If the queue is full, we cannot insert any item into the queue. So that's why I am checking queue is full or not condition. And here if the queue is empty, rear and front, I am going to initialize it to 0. If the queue is empty, my rear and front pointer will be -1. So I am going to insert a new element into the queue, so that I have to make this -1 to 0. So front and rear pointer, I have to make this as 0 when I am going to insert new element in an empty queue. And next I have to check the position of the front. If the front is less than 1, okay, if it is less than 1, that is 0, I have to reinitialize it by n-1. That is, this n-1 is nothing but last element, last position of the array. So I have to make my front as my friend points to the last position. We'll see the operation in the next video. Thank you.